Alright guys, I wrote down this topic, and the way I thought I'd start it is, about 3 weeks ago, I competed in the New Space Business Plan competition with a business plan to try to do a nanosat launcher as a business. So I'm going to give you the 5-minute or so pitch, just to give you some background on the business, and then open it up and just discuss what it takes to actually make a business out of this. My name is Paul Breed. I call myself Unreasonable Rocket. Reasonable men adapt themselves to the world. Unreasonable men adapt the world to themselves. All progress is due to unreasonable men. It's a George Bernard Shaw quote. So I build real hardware. That's my flying creature. So the goal is to provide a scheduled, predictable launcher to nanosat customers. There are at least 250 nanosats waiting for a launch. The projection for 4 or 5 years from now is over 100 a year to be launched. Right now, the only way a nanosat gets arrived at orbit is by hitchhiking. It rides with a primary payload, and just like hitchhiking, you don't have a whole lot of choices about when you go and how you go. The goal for this business plan was to do it in a way that was cash flow positive by the end of 2 years, and we have experience building real hardware. So let's go through here and talk about the hitchhiking problem. The primary problem with nanosats today, in my opinion, is that every nanosat flown to date has flown as a hitchhiker, as a secondary payload. How many people here hitchhiked to the conference? How many people rode on Southwest when you flew someplace rather than hitchhiking? Hitchhiking's free. Why would you pay money to an airline? Sounds stupid to me. The problem is, when you're hitchhiking, you don't have any control. You don't know what your schedule is, and if you're an attractive young woman and really brave, maybe hitchhiking will work for you. If you're a big, ugly guy with weird tattoos, it's not going to work so well.
When you're carrying a parachute, it works really well. If you're wearing a jumpsuit and carrying a parachute, it works pretty well.
So that's the problem with the nanosat. If you look completely benign, like an inert cube and not very interesting, you can probably get a ride. But you can't even think about looking dangerous. So no big batteries, no propulsion. You can't pick your orbit. You can't control the schedule. If you get a ride and they say, we're going to launch in 6 months, and then like this NRO bird are delayed 18 months, you have to hold your team together for 18 months waiting for your ride. How much does that cost compared to what it would cost to buy a dedicated launch? If you have a company that, you guys build real hardware. It's an iterative process. You build something, you try it, it works, it doesn't work, you try it again. If your iteration cycle is 3 years, you never get done. Or you have to have perfection on the first attempt, which is really hard. So if you're trying to do iterative development, the hitchhiker model doesn't work. Nanosats are moving from an educational niche to real properly funded businesses with real missions. There have been a number of companies that have launched their 2nd or 3rd nanosat now with real profit. We're also at the cusp of a lot of new technology, new 3D printed technology, new automated machines. It's now possible for a group of 2 or 3 or 4 to build complicated devices and complicated machines that couldn't be imagined by groups of 100, 20 years ago. The first round of private space enterprise is happening now. You've got SpaceX, Planetary Virgin, you've got the X-Corp people, you've got Maston and Armadillo. I like to use the following analogy. ULA is IBM. SpaceX has come in and built a really nice deck of VAX. It looks it's so much better than the old IBM mainframe, but it's still a deck VAX. They have 1,800 employees on staff. They've got something like 48 valves and actuators per engine times 10 per launcher. Okay. They've got, their computer boxes are still all strung together with cables with different functions. They're doing a really nice deck VAX. I want to be Apple. I want to start in my garage. There are my 2 flying vehicles sitting in my garage. So I think it's time to do it in the garage as opposed to do it in the aerospace way. My concept is a very, very simple pressure-fed launcher for 3U CubeSats. Automated construction of wound tanks, i.e. you wind on a mold with a filament winding machine. I have composite materials and resins that are compatible with my chosen oxidizer, which is peroxide. I think I fired the first ever 3D printed regeneratively cooled motor. I have over 20 minutes of firing time on that. Automated mission control. If any of you watched me do the Lunar Lander Challenge, basically I had one helper to help move physical things, and my son and I ran the whole show. And all the automation was done in a little box I carried that looked like an aluminum brick with an antenna sticking out of it, and I just pressed the button and it would go through all the checklists on the vehicle, checking all the parameters, and when it was all ready, I hit the go button. The concept is not to use a traditional range. Traditional range fees cost more than my whole vehicle. So we'll either use a small aircraft or a boat at sea, and the current concept is to stuff the rocket in something that looks like a culvert pipe, seal it in the factory, drag it out on a fishing boat, set it in the water, hook the fuel tanks up to it, back away, propellant transfer, launch, come back, get the debris that you left in the water, and go home. The concept is to do a quarterly scheduled launch. 3U launch to any orbit you want on one of our quarterly scheduled launches would be $400K. If you want a schedule that's not on our quarterly launch, it would be $600K. The price difference being the intent is to go out in the fishing boat and launch 3 or 4 or 5 at once. So you've got, so the cost of getting everybody on a boat and getting the boat out to sea and the launch area and all that is shared amongst 3 or 4 launches versus if you want one that's entirely your own, it's $600K. We've built and flown prototype versions of the most necessary hardware. The pieces we have not done supersonic aerodynamics. We have not done staging. We have built, I guess I don't have a picture in here, I do, but it's later on. We built tanks and motors of the equivalent masses and mass fractions necessary. We've built control electronics of the weights necessary. The market. Global launch market is a many billion-dollar market. I'd love to have somebody walk up and hand me a $100 million check and say, go try to compete with SpaceX, because I think it would be fun, and I think you can do it in a much lower cost way. But nobody's going to hand me that check. So this is a plan that addresses sort of the minimum business, I think, that can be cash flow positive, so that it can bootstrap itself, which is the cash flow positive nanosat launcher business. Concept being 10 launches a year is cash flow positive. This is the blue numbers are the CubeSat launches a year as of last year. I haven't put 2012 in here. I regression fit that curve with the blue with the exponential. You get the blue line. The green line is what the SmallSat conference predicts the numbers should be. Business fundamentals, 400 and 600K price points. Cost of the vehicle is about 125K. 50% gross margins at those points. Cash flow positive at the end of the year 2. And once you're cash flow positive, work on the next larger launcher.
Sorry about that. That chart of the demand, you said that's what small sats should be in that out year?
Yes. They expect over 100 by 2020. The blue line is an exponential fit to the real data. So, and I need to capture about 10 years of cash flow positive. There is what the magic chart that every business plan has to have looks like. Looking for $1.5 million to $2 million. A third of it would be for capital. A third operating expenses. A third would be salary. Then I got a bunch of pictures of hardware in here.
Ooh.
That's the ground control unit. That's what I use to launch everything. There is the first 3D printed regen rocket motor ever built. It looks like a computer rendering, sort of, because the thing on the left was 3D printed and the right parts were welded together. There's regen motor. Here is the tank. I've been working with Microcosm Scorpius. We have an agreement to develop a peroxide compatible pressure wound tank. The one on the left is after it failed deliberately. We burst it, and it burst within It burst at like 510 psi, and our calculation for that particular tank lining was like 550. So we're pretty close to the theoretical. Existing competition, secondary payloads already covered. There are people doing suborbital add-on, Virgin, X-Core. I think they still have to develop 2 stages. It's still a secondary payload because you're flying on a manned vehicle, and so you're going to have to qualify their safety things. Regulation, launching from traditional launch sites is not viable. Range safety costs are too high. I talked to the chief engineer at the FAA about this concept, and basically you set it up so, constrained by physics, the first stage can't hit anything. So you go far enough out that you can't hit anything with the first stage, and the second and third stage is too flimsy to survive high-speed flight in the atmosphere.
How far would that be out to sea?
Depends on the size.
And that's it. And
Launch
so
off the East Coast? Launch off the East Coast.
Probably
Oh, hey,
launch off
Zach.
the East Coast. And so that was the business plan I presented, but the key takeaways are a lot of people don't think you can build an orbital launcher for 125K vehicle cost. I think it's barely possible, but even with that cost, the business case says you're going to have to charge $400 to $600K for, to make the business work, and this is, talking about 8 employees. It's a really small company. So the question becomes, is there a viable launcher business at scale smaller than SpaceUp? So I'll shut up, sit down, and we can chat.
You're quoting like 125K
Yeah,
for the launch vehicle
for the entire vehicle.
that goes from the ground to
That's my cost to produce the vehicle. The price is $400 to $600K, and the actual launcher cost to do a launch standalone is about $325, or grouped in groups of 3 or 4 is about $200.
To give them some context, can you tell them how much it costs to build the blue ball and the silver ball?
Okay, so the blue ball, through the end of the LLC and everything we've done here, we spent about $500K probably. Less than that, but it depends on whether you count things like buying a forklift and buying a generator and buying a peroxide plant, and what do you put your prices? But that's sort of the gross number we spent. The blue ball I could duplicate for about $20K.
Okay, I'm just the perspective I'm coming from is that fairly low performance general aviation aircraft are in that price range.
Yeah. This is a lot simpler than that. I mean, reality is each stage has a wound pressure vessel, i.e. you make a form, you wind over it, with an automated winding machine, and you take it off the winder pretty much ready to use. You have to bolt some things on it and bond some skirts on. And the motors, the second and third stage motors come off a 3D printer pretty much ready to use. 3D DLMS printer. I've got quotes and prices on all those and have fired those motors. The first stage motor probably doesn't come off a 3D printer because it's too big. But it's going to be a simple aluminum regen motor. I'm using peroxide and hydrocarbon, and the peroxide makes a really good coolant because I got, my OF ratio is like 7, so I got 7 times as much coolant. My coolant looks an awful lot like water. So I've been able to have a fully regen cooled at stoichiometric temperatures with a 75-pound motor. That's because I'm using peroxide to cool. So I think it's doable. It's the 125K, I could be off by a factor of 50%. If I'm 50% low, the business case probably doesn't really close.
But if you're low, you can improve that over time, too.
Yes. I mean, one of the keys is you have to set up the automation. If you're only launching once a year, it doesn't work.
Yeah.
If you're launching 30 times a year, it makes sense to make the whole process almost completely automated. Now, I would point you at a company called Wellmade that makes wound fiberglass, polyethylene lined fiberglass water tanks for the plumbing industry. They sell tanks about the same size as what I want to make retail for $300. Okay? Now,
There's room.
there's room. You can get there. It's going to be hard, but I think it's possible. Now, the real question is, is it possible before you run out of money and end up eating cat food from under a bridge someplace? It's unclear to me.
So you're saying the second company that tries this is most likely to succeed?
Unfortunately, yes.
Paul, you were talking about the importance of automation in your production. What have you thought about for qualification testing in your parts before you launch them?
Well, I mean, one of the arguments I make is if the vehicle only costs $125K to fly, okay, if I'm, one of the things I would like to change is right now if I buy a launch from a traditional launch provider, the moment the rocket engine lights and it leaves the pad, they've completed their contract with me. I may have some bonus if I actually get to orbit, but I pay for the explosion on the pad. Hopefully it will go in the right direction. I get nothing if it blows up on the pad. I would like to actually treat it like UPS. You deliver a 3U CubeSat and a slip of paper that says these are the orbital elements I want, and I deliver it, and you pay me, or I don't deliver it, and you don't pay me. Which basically I would like to share that risk with the customer. You have to do it anyway as you're starting out. So to start out with, you go out and get customers and say, hey, you got some cheap CubeSat you want to launch? Give me 5 of them. I'll try to launch them. If the first 3 don't work, we won't charge you anything. I think that quantity has its own quality. If you build 100 of these, the quality will improve if you take the time to figure out why they failed in between. I mean, for a pressure-fed rocket with 2 valves, how much qualification do you have to do? You probably would want to fire the motors. You'd probably want to pressure test for leaks. You'd probably want to hydro test to operating pressure plus 10%.
Would this have helium bottles on board, or would you do partially filled tanks and blow down?
It's going to depend somewhat on what we can get for mass ratio. I'm looking at 2 schemes. One that I've thought about a lot is partially filled blowdown, where the blowdown pressure for my hydrocarbon and my oxygen are oxygen and methane respectively, and then have some sort of veneer thruster that burns the vacuum at the end. Mm-hmm. That way I don't pay for my utilage gas weight, and that actually has pretty good ISP if you're doing it in a vacuum. Yeah. So that's my favorite concept. My next favorite concept is to put LOX and liquid methane, LOX and subcooled methane, or cooled methane, methane liquid, in metal bottles, helium pressurized, but then pressurized and then burn off. Mm-hmm. But I would rather be simpler than more, adding valves, regulators, pressures, and thermal control there is a little complicated. I really like the idea of just pressurizing them with the appropriate fuel and oxidizer and burning at the end.
It sounds to me like what the concept you're trying to do here is very similar to the military sealed round.
The what?
The sealed round, like ballistic missiles.
These are not, I mean, building a tank that'll be okay with peroxide for 20 hours is very different than building a tank and system that'll be okay with peroxide for...
And it's cheap enough to have the off-board peroxide storage to transfer just
I'm paying about $4 a pound for peroxide at 90% delivered to the middle of the desert. One of our rules for peroxide handling out of FAR is once it comes out of the primary source container, it never goes back in, it goes on the ground. And so if you abort a test, you don't reuse the propellant, you pour it out. Because most of the people I know who've gotten into trouble with peroxide have gotten minor contamination doing that. So we never reuse it, not even 1 ounce of it. It all it gets in the Mojave Universal Catalyst.
And that's because every living thing has an enzyme in it. It's designed to destroy hydrogen peroxide because it's so bad for living things. That's why when you put hydrogen peroxide on a wound, it foams up. It's because you have enzymes in your skin which break down peroxide.
As a point of order, the hydrogen peroxide you put on your cut is between 3 and 4%. We're burning 90%. I'd like to go to 95, but my catalyst packs don't survive.
Wow. Okay, so the propulsion angle seems very well handled, and especially with your experience, I mean, it seems that you have it down. What are you doing? Like, how are you getting paid? Where are your customers? Where are your customers?
My customers are the 250 nanosats waiting for a ride. I need to find 10 of those. a year.
Who's been paying for their rides until now? Is it?
Well, okay, so I went to SmallSat last year, and I asked everyone I ran into the following question. Somewhere between 250 and 500K for a ride to any orbit for 3U, would you pay for it? And I got two wildly separate responses. All the academic researchers said, we don't pay anything for our rides. That's way too expensive. We can't budget it. And I asked them how they budgeted a 3-year wait. He says, well, the faculty's on tenure, and I don't care if the graduate students
Slave
are done.
labor.
You know?
Slave labor. Slave labor.
Yeah, slave labor. They didn't care. Now, all the program people said, you're going to actually launch a rocket for 500K? I walked off thinking, you're not serious. So they're grossly disconnected. The program people think the price is way too cheap, and the nanosat people think it's like ungodly way too expensive. And the reality is it's somewhere in the middle, and I think SpaceX has recently published 3U secondary payload prices of 250 to 350K, and I'm offering 400, where you can have propulsion, you can have big batteries, you can have megawatt radio transmitters, whatever you can cram in the container, you can launch and get the State Department to stamp it's okay to launch on, I'll launch. So, you know, and if you don't have to do any qualification, you don't have to convince the primary payload that it's okay. You probably want to do shake and bake and back and vibe. You really want your satellite to work. I don't care. You know, you do whatever you think you need to do. If you want propulsion, put propulsion on.
So academics have been getting basically free rides from NASA on a sounding rod.
Well, there's an interesting argument that NASA, under law, once a service becomes available commercially, has to purchase it commercially. They haven't, I mean, look at the war that was necessary to get the zero-G flights done that way. They don't always play along. But if you want to go play that role, you can say you have to stop giving away free rides now because I'm offering a commercial service, you're competing against me, and you're counter to your own law. So you can make that argument, in which case NASA probably has to start paying you or kill the whole nanosat business. But
that didn't stop NASA from putting random.
That would be a bad outcome.
I don't know that it would be a bad outcome. I actually think long-term it's the right outcome. Because,
I mean,
What kind of
academics
messes
will
with
still
your
want to
business
fly.
case
yeah,
now?
they'll figure
find a
out.
way.
They'll figure out a way.
By the way.
So the 3U form factor is interesting. You can pack a lot in it. I've heard also some folks talk, I was hoping John Schilling would be here, I don't think he is, that 6U would kind of be able to do a little bit more, I mean, for a lot of reasons.
I've had a number of people ask me, so can you make this 6U and bigger? And I picked 3U for a reason. It's the smallest I think is commercially viable. Also, in big dumb rocket mode, at 3U, the rocket is still handled by humans. I don't need cranes and fixtures and strong backs and forklifts and all that stuff. 2 guys can pick it up, move it around, and roll it over if you got to hold something on the other side. When you start going up 6U, it might be humanly handleable. Okay.
As long as one of them is Samoa.
One of them is an Olympic class weightlifter. But once you go over that, you start getting to the point where now, rather than just rent any old fishing boat that's got a net lift in the back, I'm talking about special fixtures to set it in the water, things like that.
Are you going to be launching this like the Sea Dragon, like from the water itself?
Yes, put it in the culvert pipe. Honest to God, chunk of culvert pipe with, long enough that it floats like a spar buoy with a weight on the bottom. Yeah.
The world's largest bottle rocket.
Yeah.
The world's largest bottle rocket.
Exactly.